This is Mario with MIM Microflight, and in this video I'm going to be talking about how to make a smoke little engine for model trains. I'm going to talk about things that they don't talk about in other videos because I have seen many videos that have similar components, such as the heater, in this case a motor with a pump, an air pump. They don't talk about the details of what size wire, what type of wire, what resistance, and what wattage. And so I'm going to be showing you how I arrive at these particular things here. First of all, you're going to need a piece of nichrome wire. This is the wire that I'm using here. It's very thin wire. I'd say that this is about maybe 1/64th, even 0.1 of an inch, in 0.001 rather, not 0.1 but 0.001. It's very thin wire, and where you get this wire is you get a hair dryer, an old hair dryer, and you just disassemble it, and typically that comes as the base wrapped up in a coil like that, like this. In fact, I was using this as my test coil here that has that fiberglass insulation inside. Be careful with this fiberglass insulation when you use things like that you do this outside. You remove that fiberglass insulation because it's it turns into very fine powder, and you can easily breathe that if you're not careful. That's not good for you, for your lungs. Very dangerous. So that's how you get the nichrome. You could also use this portion of the nichrome wire here, but this is a lot thicker, and what you want is you want the thinner stuff. The size of the length of the wire is determined by how many watts and what type of current you want to pull from the power source. In this case, because this is going on a model train, I am going to I targeted this at 3 volts max, and so that's how I size my wire, and that's how I size also the current that goes through here and the length of the wire. So this particular wire happens to be such that it runs on 6 volts at 12-inch for a 12-inch length. So if you were to connect plus and minus, or either way, it doesn't matter with the polarity here with this, because it's just a heater. If you connect a length of 12 inches to a 6-volt power source, you're going to get about 0.3 amps current draw. At 3 inches, which is what not 3 inches, it's 6 inches, which I decided to cut this wire. I am pulling, and I'll show you here in a minute. I am pulling at 3 volts. I am pulling about half an amp. As you can see, it's beginning already to smoke here. And so at 3 volts, half an amp, that's about 3 times current times voltage equals power or wattage. So that's 3 volts times 0.5, that's 1. I'm drawing, this is working at 1.5 amps, 1.5 watts rather. So it's the heater works between, if you want to heat this and you want to use oils, and I'm just using just a scented oil here just for the demonstration here, but there are some other oils that you can use that are not going to be smelly or dangerous, to your health. You can see that at 1.5, all I have to do is heat the oil with my coil here. Be careful with the oil. The coil gets really hot. Not super hot, but it gets hot at 1.5 watts. You will feel that. So all this has to do is touch the surface of the oil, and you can see how it's creating the smoke here. Now, I've seen people use cotton and paper and all kinds of things, and I've experimented with that as well. But you can see what happens with the cotton when you wrap this around the coil. In fact, this can create a fire, and you don't want that. What you want is just the coil to be touching the surface of the oil here. So in order to do this, to make this into a working system, such as tubular stack, it's going to produce a smoke in some realistic form for a model train. This has to be fully enclosed in a container that's, number one, it's not going to leak. Number two, it's not going to be conductive on the side walls. And it's going to have some kind of a pan reservoir for the oil, so that the coil can just touch the surface and create the smoke that you're seeing here. It doesn't seem like a lot of smoke, but when this is in a container, when you start enclosing this, let's say if I were to put this in a tubular section or a tubular piece of a little stack, it does create quite a bit of smoke. And so the idea is, like I said, just to have the coil touch the surface of the oil there, so that it burns the oil and it doesn't burn cotton or fiberglass. I've seen people use fiberglass and cotton. You could use fiberglass here, because fiberglass is it has insulating properties while retaining the oil, but in my opinion, this is the way to do it. Just touch the surface of the oil. So I'm going to be working on a container that's going to have a little pan there for the oil, and where this is just touching the surface. Another thing we can do here is just have like a dripper system, where it just drips a little bit of oil on the surface of the coil, so that it provides so it's able to heat, because you don't want to immerse this totally in oil, because then you're going to have an insulator there and it's not going to heat up properly. So you just want to touch the surface. Notice that when I touch the oil and I lift this up, it creates smoke on just by the mere fact that it has oil on the surface of the coil. So what you want to do is just have the oil on the coil. And if we can do this at intervals, with some kind of a dripping system. It could also be an electronic pump, just a 3-volt little pump that pumps the oil, into the container where the coil is suspended. We can activate, the smoke effect. Once again, this is running at 3 volts, a half an amp. I could lower this to 2.5 volts, because this particular coil at 6-inch length coil, the way it is, I'm kind of losing a little bit of length there by the connectors there. Those are just connectors that I use from this JST plug, and it's been JB welded to a fiberglass sheet of material here. And this was just to do the testing here. So this will work between anywhere upwards of 1 watt. So 1 watt is the point of reference here. And so that's how you make a coil that's going to heat up, some oil, to create the effect of the smoke stack. Now you'll notice here a few components on my work table here. There's a resistor. This is a 1.5 or 15 ohm resistor. You can also do this with a resistor by figuring out, the voltage that you want to run this at, and the current. This resistor, this is 15 ohm. This one right here is 10 ohms, and you can see what happens to the resistor when it gets heated. it starts to get dark and starts to burn actually. So a resistor would also work, but it's not as good as a nichrome wire coil. This can be enclosed in an enclosure where it has a little pump like this. And I bought these pumps because they run also at 3 volts. This is just an air pump. I think they use these for aquariums. I've never seen an aquarium with this type of pump. I don't know how they use these in aquarium, but I guess just to pump air into into a tube and then have that as a bubbler inside the water tank to provide oxygen, to the water. So I ended up buying a couple of these, and I've been experimenting also with this in a little stack here that has a little bit of that has a hole here, and I had this inside this tube here. But the tricky thing is that this is a little bit too narrow in outside diameter or inside diameter, so you don't want that touching the walls of you don't want that touching the coil. And so I'm going to make a bigger one and embed this pump in there, and that should provide the air. This can also be done with an electronic circuit that pumps it at intervals. It's not constantly on. That way you conserve energy on the motor power. That way you're only pumping as this is heating up the oil, and it's built. And as the smoke builds up, you can just pump it at intervals. Boom, 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 boom. So that's what I intend on doing here. I've also ordered some misters. Another way you can create the smoke effect is a lot of people are using misters. This is my first time experimenting with these things, and so I'm eager to try the misters and see how well that effect is. From the videos I have seen, the misters seem to provide a very nice effect, but unlike burning oil as you're doing with this heater here, the mister is it uses a piezoelectric element that vibrates at a certain frequency that's predetermined by the design of the circuit board, the electronics, and that vibration creates breaks down the water surface that it touches, and it creates a mist. So basically, you have a mist of water. I'm not sure how that's going to work with a model, because now you have moisture around any surface around that unit. So, but it is an option that I've seen people use. I'll be experimenting with that myself, and after I do that, I'll decide which system I'm going to embed this on my little model train that I've been showing in my other videos. Once again, this is Mario with MI Microflight. And here's some additional information in addition to all the videos that show you, how to do these things, but they don't quite tell you, what length, what type of wire, the mechanics of this, what resistance, what wattage, and the why. So I hope this is helpful. Thanks for watching.